All right, this set of notes, we're going to start with the area of triangles. Okay, to find the area of a triangle, we take 1/2 times its base times its height. Okay, it's important to remember, even though base kind of makes it seem like we're always going to use what's on the bottom. Okay, we need to make sure that the base that we're using and the height that we're using are perpendicular to each other. Okay, so here in this picture, the bottom part of this triangle is perpendicular to this dotted line here. Okay, so those two are what we're going to be multiplying together. Okay, so some examples. We're trying to find the area of the shaded triangle here, okay? So even though this 8 looks like it's part of the base, we only want to use the part of the base that is actually like a part of that triangle. So 22 is our base, okay? This 8 is an extension of that base. So 16 here, where I see that perpendicular symbol, that is the height of the triangle. Okay, 8 and 34 right now are just extra pieces of information. So 1/2 base times height, I'm going to replace B with 22 and H with 16. Okay, I can multiply those straight across. So 1/2 times 22 times 16 means that the area of this shaded triangle is 176 feet squared. Okay, so if we've got an obtuse triangle, our height can be outside the triangle. Okay, here with an acute triangle, our height is actually inside. Okay, which you guys are probably accustomed to seeing. So 21 is our height, 26 is our base, and I'm going to substitute those two values in to my equation. Okay, 1/2 times 26 times 21 gives me 273, and my units are meters squared. Okay, with a right triangle, so if our triangle has a right angle in it already, those two sides that make the right angle, okay, the legs of the right triangle, if you remember that from the Pythagorean theorem, those are the two numbers that we're going to multiply. It doesn't matter which one you make the base, which one you make the height. Okay, at this point they are interchangeable. But we are still going to substitute those two numbers in to our equation. Okay, and 1/2 times 40 times 42 tells me that the area of this triangle is 840 square feet. Okay. Now, sometimes we might be given the area. Okay, this one, we don't know our base, so that's what we're trying to find. But we know our height is 9. Okay, so in this equation, 1/2 base times height, we're going to substitute these pieces that we know. Okay, area is 72. I don't know the base, but I know my height is 9. Okay, a couple different ways we can go about solving this. Okay, one way we can go ahead and multiply the numbers that we have on this side. Okay, the left side stays the same. 1/2 times 9 is 4.5. Okay, and then we divide both sides by 4.5. Okay, if you don't like the fractions and decimals, If you want, you can multiply both sides by 2 first, and that will eliminate the 1/2. Okay, and then you just divide by whatever's left. Okay, either way, we find that the base of this triangle is 16 centimeters. Okay, so when you are given the area and you have to work backwards, we stick with normal units. Okay, it's only when you're finding the area that we have to have square units. Okay, now regular polygons, remember, mean that all sides are congruent and all angles are congruent. Okay, so I want you to think of a regular polygon like a bunch of congruent isosceles triangles put together. Okay, so this will say this is an isosceles triangle with these two sides congruent. Okay, here we've got a base of a triangle and a height of a triangle. All right, how that translates to regular polygons. Okay, the base of the triangle is actually the side length, or the length of one side of a polygon. Okay. So again, the base of one triangle is the side length. Okay, so rather than 1/2 B, S for side length is going to replace B. Okay. The height of the triangle is what we call the apothem. Okay, and we will define the apothem on the next page. And it's like saying a possum, but with a lisp. Okay. So rather than H in our equation, we're going to have A. Okay, and then the only other thing that we need to consider is the number of congruent triangles is the same as the number of sides. Okay, so where we did have A equals 1/2 BH for just one triangle, remember S replaces the B, the A replaces the H, and then we multiply by the number of sides because that's how many of those congruent triangles there are. Okay. Now, the apothem, that goes from the center of the polygon, and it is perpendicular to one side, just like the height is perpendicular to the base. Okay. But up here, what we talked about, that's how we get this equation for finding the area of a regular polygon. Okay, again, A is the apothem. That's that new vocab word. S is the side length. N represents the number of sides. Okay. In a regular polygon, if we take the side length times the number of sides, which is this last little portion here, that actually tells us our perimeter. So this 1/2 times the apothem times the perimeter is actually a second way to find the area of that regular polygon. Okay, so capital P stands for perimeter, and you will only use this second one if you're given the perimeter. Okay. All right, so these examples here. What I like doing is I like defining my variables first. Okay, in this picture, my apothem from the center to like the middle of one side is 4.15. My side length is 4. Okay, and then looking, I'm just going to count the number of sides. I've got 1, 2, 3, 4, 5, 6, 7 sides. Okay, so now in this 1/2 ASN equation, I'm going to substitute 4.15 times 4 times 7. Okay. And you can just multiply across. It doesn't have to be in any special order. Okay, and that tells me that the area of this regular heptagon is 58.1 square meters. Okay. Now this one, I'm given my perimeter. So that now we're going to use that second equation. My perimeter is 40. Okay, my apothem from the center to one side, the apothem is 6.16. Okay, so in that A equals 1/2 AP, those two numbers are going to replace my two variables. Okay, so 1/2 times 6.16 times 40 tells me that the area of this regular decagon is 123.2 square yards. Okay, so that's finding the area. But now we can work backwards. If we know the area, we can find a missing piece of information, okay? So my apothem in this example number 4 here, I don't know what that is. So that's what I'm trying to find. Okay, my side length is given to me here. That's 12. Okay, and please don't forget N just represents the number of sides. So we can just count 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay. I'm going to substitute into 1/2 ASN those pieces that I know. Okay, my area is 695.52. I don't know my apothem. My side length is 12, and I have 8 sides. Okay, now what's going to be easiest, I think, for these is let's go ahead and we're going to multiply 1/2 times 12 times 8. Okay, my left side stays the same for now. 1/2 times 12 times 8 is 48. And then I will divide both sides by 48. So that tells me that my apothem is 14.49 feet. Okay, and again, working backwards, when we're just finding a piece of the polygon, we use regular units instead of square units. Okay, number 5 here, I'm given my perimeter. Okay, so I'm going to be using the 1/2 AP. All right, I've got perimeter, I've got area. I do not know my apothem again. Okay, so I'm going to substitute 337.05 1/2 times the apothem that we don't know times my perimeter. Multiply the numbers that I have on the right side. Okay, my left side stays the same. 1/2 times 70 is 35. And then to find the length of my apothem, divide both sides by 35. It tells me that for this pentagon, my apothem is 9.63 inches. Okay. Last example here with a picture. I'm looking for my perimeter. I have my apothem. Now that's 8.24. Okay. So again, I'm going to be using 1/2 a capital P, that equation. Okay. I'm going to substitute what I know. I know my area is 222, not 228. 222.48. My apothem is 8.24, but I don't know my perimeter. Okay, again, on that right side, I'm going to multiply those numbers that I do have. Okay. The left side stays the exact same. 1/2 times 8.24 is 4.12. Okay. And that's what I divide both sides by to find that perimeter. Okay, the perimeter of this 1, 2, 3, 4, 5, 6 nonagon then is 54 meters. Okay. These last two examples have to do with finding the number of sides, okay? So I'm still going to define those variables. Okay, my area is 439.14. Side length is, remember, the variable lowercase s, that's 19.5. In, we don't know. And then the apothem is 5.63. Okay, so I'm going to substitute these values in. Okay, 439.14 equals 1/2 my apothem, my side length, and in. I don't know that number of sides that I have. Okay, just like what we've done so far, we are going to multiply these three things together. Okay, that'll really simplify that right side of the equation. So 1/2 times 5.63 times 19.5 we'll say is 54.8925. My left side stays the same. Okay. Divide both sides by 54.8925. Okay. And I get n to be 8.000001, which leads us to just 8 sides. Okay. Example 8, when it asks us what polygon, that means we first need to find how many sides. Okay. So our area is 232.68. Our apothem is 8.31. Our side length is 8. And before we can determine what polygon, we need to know the number of sides. So substituting area 1/2 the apothem times the side length times the number of sides. Okay, so that first step that I like to do after I have established what those variables are is go ahead and substitute each of those in. Okay, I'm going to multiply all three of these pieces. The left side of my equation stays the exact same. And 1/2 times 8.31 times 8 is 33.24. And when I divide both sides by 33.24, n equals 7. So this polygon has 7 sides, and the polygon that has 7 sides is called a heptagon. And your notes are done.